All right, guys, so I'm going to go ahead and just explain a little bit of how I actually do transformations. You guys saw it in class. What I do is actually take a much more complicated problem. I break it into smaller, simpler problems, and then we just plot points and actually graph. I don't do it in the traditional method, like we're going to move things to the left or right so many units, or up or down so many units. I like going back to the ideas of Algebra 1, which at this point you guys are really good at. So we're going to look at this first example here. We have f of x equals x minus 3 squared plus 1. Well, the first thing I always ask myself is, what is my parent function of this? So my parent function, and you know I can't spell, so I'm probably misspelling this. My parent function here is going to be f of x equals x squared. And of course, you know that this is going to be a parabola. So when we graph it, we're going to graph a nice little parabola here. We are going to have points at 0, 0. And of course, we'll have a point at 1, 1. And then we'd have another point over here, which is at negative 1, 1. We're going to use those 3 points to actually help us to actually transform this. Now, of course, you do have to remember everything on the inside affects the x's, and it's the opposite operator, and everything on the outside affects the y's at face value. So let's just kind of figure this out, how we're going to do this. All right, so here we go. First thing I'd say, let's just start with something that you're really good at, which is just making a table. So I'm going to start with my x and my y values. These are going to be my parent functions. Let me use the same color. My parent function is blue. So we're going to do an x and a y value. And of course, then when we have the point x values of negative 1, 0, and 1, it becomes 1, 0, and 1. And that's from those 3 key points I put on the parent function over there. Now what I do is I actually add to this table, where I'm actually going to start calculating what I need to do. And I want to go ahead and graph the new graph in purple here. So I want to make equations so I can find the new y value and x value, though, of these points. Well, outside the parentheses right here, we have a plus 1. Anything outside the parentheses affects the y. So we're going to do, and we're going to take it at face value, so we're going to do y plus 1. So we put 1 in right here. We're going to put these values, 1, 0, and 1, into my equation here, y plus 1. When I do that, I do 1 plus 1 is 2, 0 plus 1 is 1, and of course 1 plus 1 is 2. These are my new y values. Now we need to go ahead and work on my x values. Right here, inside the parentheses, I have x minus 3. And what we're going to do is, what are we doing to x? Are we multiplying, or are we adding, subtracting? Well, in this case, it's actually subtracting 3, but we're going to do the opposite, because it's everything inside the parentheses affects the x's, but it's the opposite operator. So if we're minusing 3, we're going to have an equation of x plus 3. So when we do that, we do our x plus 3, it just becomes pretty straightforward. We're going to take these x values, we're going to plug it in right here. We're going to do our arithmetic. And of course, then when we do the arithmetic, negative 1 plus 3 gives me 2, 0 plus 3 gives me 3, and 1 plus 3 gives me 4. These right here are my new x and y values. So when I go to graph it, drag this over, make it a little bigger. So when I go to graph it here, so I'm going to go ahead and just pick a spot for my origin right here. So that's 0, 0. And we need to plot 2, 2. So 1, 1, 2, 1, 2. So we're going to have a point right there. We're going to have a point at 3, 1, which is right here, and a plot at 4, 2, which is right here. And at this point, we just draw in, play connect the dots with our general shape from our parent function for the parabola. So this would be the transformation. This right here is the transformation of this. We use the parent function x squared. And what we do is we end up having to move it up 1 unit. So you can see that this is indeed moved up 1 unit. And then we had to move it, let's see, -3. So we're going in the opposite direction. We had to move this direction in the positive direction 3 units. And then it's the same graph. All right, guys, so I'm going to go through this one just a tad bit faster. Nowhere near as in detailed as just a second ago. But I want to ask you to graph something like f of x equals the square root of negative x plus 1. So, of course, then we're still going to do the parent function. Our parent function is going to be f of x equals the square root of x. And if I were to graph my parent function over here, which I'll do it in blue, right here, we're going to have a point here, and it's going to kind of come up like this. We're going to have key points at 0, 0, and of course at 1, 1. You'll really only need to do 2 points on this parent function to actually figure out what's going on with the transformations. Now we have a thing where if it's inside the parentheses, and really, if in this case, if it's really inside what your parent function is, it's going to affect the x's, and everything on the outside affects the y's. So we're going to go ahead and make a table, and so I'm going to do my x and my y. The first part of my table is going to be for my key values on my parent function over there, which is 0, 0, and 1, 1. So we do 0, 0, 1, 1. Now we can add in these other columns, and we are going to go ahead and do our transformations. Everything on the inside is opposite, but affects the x's, everything on the outside. Well, we don't have anything on the outside, so it just becomes y, so we have a 0 and a 1. But on the inside, we have a negative. That means we're multiplying by negative, so really we need to divide by negative. So we're going to have a negative x, and we have a plus 1. We're going to do the opposite, which is minus 1. So when I put this in here, when I put 0 in for my x, 0 times a negative 1 is still 0. Minus 1 gives me a negative 1. And of course then my x with 1, when I put 1 in here, I get negative 1 minus negative 1, which actually ends up being negative 2. So then all we need to do is just come over onto our little graph paper here, because these are our new points. We're going to go ahead and plot these. Let's just say we're going to do it right here. We need to plot a point of negative 1, 0. So we have negative 1 and 0 right there. And we need a point of negative 2 and 1. Negative 2 and 1. So what I can see my general shape is going to be something along these lines. And it just kind of makes sense, because if you have any number greater than 1, you're going to get an imaginary number if you put in there. So you're going to have a pretty small number, negative 5, negative 6, because if you do negative 5 plus 1, you get a negative, multiplied by negative is a positive. It is a reflection. In this case, if you look, it's a reflection across the y-axis, which actually affects the x values. Then, of course, we did shift it. We did a horizontal translation. Just review this as many times as you need it. If you have other ways that you're good at transformations, by all means do it. If not, try my way. Go back to the really basics. Break them into 2 different equations. Use your the whole idea of linear equations and where you're plugging things in, and then just going back to plotting points.